All right, guys, good morning. Welcome back. This is Summer 2024, Barron test number 1. Last time we left off right here in number 21. Dice, a particle moves along the line with velocity in feet per second given by t squared minus t. The total distance in feet traveled from 0 to 2 equals. Okay. Oh, this graph is not for this one. Well, to find the total distance traveled, we're going to do the integral from 0 to 2, the absolute value, d of t dt. I do want to keep in mind that because I don't have a calculator, I need to know if there's any negative area. So we're going to do this. T squared minus t is equal to 0. We're going to factor out a t, and we're going to find our x-intercepts. Now, let's take a look. Since we're doing the integral from 0 to 2, and my x-intercepts, aka my critical points, are 0 and 1. I put them on the number line. And I'm going to quickly see what happens with, what is velocity here? So if I plug in anything between 0 and 1 into this guy right here, if I plug in, like, for example, say 0.5, I'm going to get a positive times a negative, which is a negative. And if I plug in 1.5, I'll get a positive times a positive, which is a positive. So that tells me what I want to know. That part of the area is negative. So I'm going to do the integral from 0 to 1. And we're going to do the integral from 1 to 2. So, okay, let's get the first one. The antiderivative is going to be 1/3 t cubed minus 1/2 t squared, evaluated from 0 to 1. And for the second integral, I'll do it in a different color, but the same antiderivative. Oh, wait. There should be a difference. Minus t squared. Oh, another mistake. Oh, luckily I'm catching them pretty quick. Here, let me fix this. All right, so this is going to be 1/3 minus 1/2 minus 0. And over here, we're going to have, when I plug in the 2, we're going to get 8/3 minus 1/2 times 4. And then plug in the 1, so we get 1/3 minus 1/2. Okay. Yeah, you know what? Let's go ahead and get a common denominator here. We have 2 over 6 minus 3 over 6. And same thing over here. Let's just get a common denominator of 6. 16 over 6 minus 12 over 6. And I'll also distribute the negative, might as well. Common denominator, 2 over 6 plus 3 over 6. Now over here, we're going to get 1/6. And even though it's negative, I'm going to keep it as a positive because we were taking the absolute value, if you recall from the beginning. Plus 16, 4, 2, 5. And it looks like the answer here is 1. Oh, don't want that. There we go. 22. The graph of f prime is shown in the figure above. Of the following statements, which one is true about x is equal to 1? Okay, so once again, we have the graph of a derivative, right? Just want to emphasize that. F is not differentiable at x equals 1. This one is false because the graph shows me that f prime of 1 is equal to 3. I mean, there's a point right there, right? I think the mistake that we would make is that we are thinking about differentiating f prime. So in other words, f double prime is not differentiable at x equals 1 because there's a corner. F is not continuous. Well, because it's differentiable, it's also continuous. F attains an absolute maximum. That is false. I mean, if you look at the graph for what it is, there is a maximum, but we're not asking for the maximum of f prime. We're being asked for the maximum of f. And that would happen if, first of all, one of the conditions would be for us to cross the x-axis, right? For going from positive to negative. That's not the case here. The other scenario would be if the graph stops right here, then the endpoint of 5 would be the maximum because we have all this positive area. And we would still have to calculate the negative area here to even like test it. There is a point of inflection. This one is true because the second derivative at x equals 1 is undefined. And not only that, if you look at the signs, f double prime of x is positive, and then f double prime of x is negative. Like it literally switches signs. So D. A series question. Okay, the Maclaurin series for the function h is given, and it converges to h on the interval from -3 to 3. If h of 1/3 is approximated with a 6th degree Maclaurin polynomial, what is the alternating series error bound? So before I even do anything, let me go ahead and put my formula. S minus S of n is going to be less than or equal to the absolute value of a of n plus 1. That is what the alternating series error bound says. So, I guess the first thing I need to know is figure out how many terms it takes us to get to the 6th degree. Because once I know how many terms it takes us to get there, then I can take the next term to find the alternating series error bound. So let me just start getting some of these terms. When n is equal to 1, if I plug in 1 into n into my series, I'm going to get -1 to the power of 0, x to the power of 2, 3 squared times 1. If I plug in n is equal to 2, then I get -1 to the power of 1 times x to the power of 4 divided by 3 to the power of 4 times 2. And if I plug in n is equal to 3, then I get -1 squared, so I'm not going to write it. 3 to the power of 6 times 3. Okay. And I'm going to stop right there because I already have my 6th degree. So it took me 3 terms to get to the 6th degree. So now, to find the alternating series error bound, I got to go ahead and get the 4th term, just the 4th term. I might as well show you guys up here. It's going to be -1, if I plug in the 4th, to the power of 3 times x to the power of 8 divided by 3 to the power of 8 times 4. And yeah, I got to use that. I got to use the 4th term. But not only do I have to use it, I also have to plug in 1/3 for my x. So that's going to be -1 times 1/3 to the power of 8 divided by 3 to the power of 8 times 4. Don't freak out about the power of 8s. What I'm going to do is I'm going to say -1/3 to the power of 8. And then this denominator, let's just multiply by the reciprocal. which gives me negative 1 over 3 to the power of 16 times 4. So, B. Find this antiderivative. Because we have a product rule, the first thing that I think about is integration by parts. So let's say u is x, the u is dx, dv is cosine, v is negative sine. Wait, no, positive sine. Okay, so write down your formula, plug in your terms, get the antiderivative. Oh, antiderivative, I said. The antiderivative here would be cosine, negative cosine. So let's just make that a positive. Giving us A. Which of the following series converges? Well, this one is a P series, and look at the power. This one diverges. This next one can be compared to the harmonic series, but because this denominator is greater, that implies that this fraction is bigger. And because this series diverges, then the other one also diverges. Okay. C can be compared to the same thing. You can compare it to the harmonic series 1 over n. And for the same reason, it diverges. This next one can be compared to the P series 1 over n squared, because P is greater than 1, converges. And also, the one that we're using to compare it with is greater. So, this one converges. 26. The coefficient of x minus 8 squared of the x minus 8 squared term in the Taylor polynomial for x to the power of 2/3 centered at 8 is. Okay. Let's not overthink it. Let's get our generic form for the Taylor polynomial. So we have fc plus f prime of c times x minus c plus f double prime of c times x minus c squared plus f triple prime of c. Okay, I'll stop right there. I don't know how many I need, but let's just go ahead and get some derivatives here. Yeah, my first derivative would be 2/3 x to the power of negative 1/3. My second derivative would be negative 2/9 x to the power of negative 4/3. And, well, I mean, I'm just looking for the coefficient of x minus 8 squared. And x minus 8 squared is going to be located here, which means I need to calculate this part. So my second derivative would be centered at 8. It's going to be the cube root of 8 to the power of 4, which gives me the cube root of 8 is 2. 2 to the power of 4 is 16. Then 16 and 2, you can simplify that to 1/8, which is negative 1 over 72. But that is still not the correct answer, because don't forget about the denominator of 2. So this divided by 2, or in other words, multiplied by 1/2, it's going to be negative 1 over 44. Oh, wait, I just said negative, and I'm circling the positive. There it is. 27. So we have a derivative, we have g, find this derivative. Okay, chain rule. F prime of g times g prime of x And we already know that f prime is h. So h. Oh, and g of x is x cubed. G prime would be 3x squared. So the answer looks like it's C. 3 more to go. Number 28. Calculate this integral. So the antiderivative of e to the u is e to the u. But then think about getting the derivative of negative x over 2. It's going to be negative 1/2. Because we're going to have to, we need to multiply by the reciprocal of that, since we're doing an antiderivative. This gives me negative 2 over e to the x over 2. Plug in your values. Negative 2 e to the infinity minus negative 2 e to the 0. The first fraction, that one's going to basically go to 0, plus 2 divided by 1. So the answer is 2. The graph of f consists of 2 line segments as shown above. G is f of x inverse. Find g prime of 4. Okay. If we want to find g prime of 4, first of all, I kind of always forget the formula for derivative of inverses, but what I do is I set up my composition of functions that show that they're inverses. F of g of x equals x. Inverses cancel each other out, leaving you only with the variable. So now I can take my derivative. F prime of g of x times g prime of x is equal to 1. Plug in the 4. Now g of 4. We already know g and f are inverses. So g of 4 is the same thing as saying f of something is equal to 4. And that would be, if you look at the graph, that would be 5. F prime of 5 is the rate of change at 5. Let me erase my lines right here. To figure out the rate of change at 5, I can do a rate of change because it's a linear function. So here the rise is 4, the run is 6, which means the slope is 2/3. This means that g prime of 4 equals 3/2. Okay, last one. Come on. If the computer wants to scroll up. Okay. Choose the integral that is the limit of this Riemann sum. Okay, first of all, let's remember the structure of the Riemann sum. When you have a Riemann sum, we have b minus a over n times f of a plus b minus a over n k. I mean, and the way they presented it to me, it's out of order, right? But look, we can see what b minus a is. And not only that, when you look at the inner structure of the function, a is kind of isolated. So I already know that. I know that a is going to be 2. We also know that b minus a is equal to 3, which means that b is 5. So there's my clues already. A is 2 and b is 5. That's your limits of integration, which leaves us with a and c. That right there. Yeah, that right there should be enough. In addition to that, this part is usually just your x, especially when you have it like in this simplistic form where you just have a plus b minus a over nk, which means that this is going to be c. Oh, look, because we also have a square right there. I missed to point that out. So the function is x squared. And that covers the first part of the multiple choice. I'll see you soon for the next one.